Welcome to another Mathnificent conversation. Today we're going to continue with our featured guest, factoring out the greatest common factor. But today we're going to step up the problems just a little bit and we're going to focus on factoring out a binomial greatest common factor. Okay, let's say we're asked to factor the expression 3x times the quantity x minus 1 plus 4 times the quantity x minus 1. Okay. We remind ourselves in this expression, this is our first term and this is our second term. So I'm going to rewrite so we can see our GCF clearly. In my first term, which is 3x times x minus 1, I have an x minus 1. And in my second term, which is 4 times x minus 1, I also have an x minus 1, which means both terms have a common factor of x minus 1, and they don't have any other common factors because 3x and 4 are relatively prime. Relatively prime meaning don't have any common factors. So I'm going to go ahead and I'm going to factor out x minus 1. When I divide out x minus 1 from my first term, I'm left with 3x. Plus, when I divide out x minus 1 from the second term, I'm left with 4. So the expression we started with factors into x minus 1 times 3x plus 4. You always want to double check and make sure what you factored cannot factor any further. And so x minus 1 is prime and 3x plus 4 is also prime. So we are done factoring that expression. Okay, let's look at the problem. Factor negative 5x times x squared plus 1 plus 5 times x squared plus 1. So again, let's get our minds in where our terms are. This is a term, and this is a term. I'm going to rewrite so we can clearly see our GCF. So we have negative 5x times the quantity x squared plus 1 plus 5 times the quantity x squared plus 1. So all the things that are like terms or common terms, I've made the same color. So let's take a look at reminding ourselves where our two terms are. Both terms have a common factor 5, and both terms have a common factor x squared plus 1, which means our GCF is 5 times x squared plus 1. We can divide this GCF out of both terms. So if I factor out 5 x squared plus 1, when I divide that out of my first term, I'm left with negative x plus, now I've divided that entire thing out of the second term. 5 divided by 5 is 1. And x squared divided by x squared plus 1 divided by x squared plus 1 is also 1. So now I'm left with negative x plus 1 when I factor out my GCF. Now, mathematicians are very specific about how things look. We typically do not like to leave a leading term negative. So in this quantity, negative x plus 1, my leading term is negative x. So there are two ways that might be compensated for. The first one is factor out a negative 1 from negative x plus 1. So I'm going to factor that out, and I'm going to put it in the front. Factoring out a negative 1 from that factor means I'm dividing it by negative 1. So that's going to give me x minus 1. Notice the negative 1 only divides out of that term, not all of the terms. You might also see that written as just negative 5 x squared plus 1 times x minus 1. Another way is they might just rearrange the term. So 5 x squared plus 1. And instead of writing negative x plus 1, you might write 1 minus x. So all of these are equivalent statements. So you want to keep your eye out and knowing how all the different ways you can rewrite things in an equivalent manner, just in case it's a multiple choice exam, and just getting into the habit of rewriting. But typically, we do not leave leading terms negative in that way. Okay, our next example, we want to factor x squared times 2x minus 5 minus 9 times 2x minus 5. Get our mindset and where our two terms are. That's our first term and that's our second term. I'm going to rewrite so we can see factors that are similar in each term. Okay, now I can see that my first term has a 2x minus 5, and my second term has a 2x minus 5. And x squared and 9, again, are relatively prime. They do not have any common factors. So that tells us our GCF is 2x minus 5. I'm going to factor out 2x minus 5. When I divide out 2x minus 5 from my first term, I'm left with x squared. And when I divide out 2x minus 5 from my second term, I'm left with 9. Now, again, you always check. Once you factor out a GCF, is there anything else I can factor? This statement here is a difference of two squares. And if you're not familiar with difference of two squares, check out the difference of two squares video, because it is one of those factoring techniques that never goes away and always comes up. So x squared minus 9 will factor into x minus 3 times x plus 3. And now all of my factors are prime, so I factored the original expression completely. For our last example, made it a little bit more complex. So let's look at our terms. Our first term is 3x cubed times x plus 7. And our second term is negative 10x squared times x plus 7 squared. Let's rewrite 3. I have an x. Then I have this x plus 7 minus 10. Uh-oh, I have another x. And I have another x plus 7. Now, if you notice, I kept the exponents in the original color, and I've only rewritten the factor in its own separate color. So both terms have an x factor, and both terms have an x plus 7 factor. But they don't have the same amount. Okay, so technically, Our first term has 3 x's that are multiplied, and our second term has 2 x's. So I'm going to rewrite this without the exponent so you can see clearly how it works. So x cubed is equivalent to 3 x's. X squared is equivalent to 2 x's. And then x plus 7 squared is x plus 7 times x plus 7. So now we can see from both terms, I have at least 2 x's. And from both terms, I have at least 1 x plus 7. And then 3 and 10 are relatively prime. They do not have any common factors. So our GCF is x squared times x plus 7. Okay, so we're going to factor out x squared times x plus 7. From my first term, here's my first term here. If I divide out x squared from x cubed, I'm left with 1x. If I divide out the x plus 7 from x plus 7, x plus 7 divided by x plus 7 is 1. So times 1, and then our 3 is still there because there was nothing to divide out. Minus, if I divide out x squared from x squared, that's 1. And if I divide out x plus 7 squared, x plus 7 from x plus 7 squared, I'm left with 1 x plus 7. And then we also have our 10. Let me rewrite a little neater. This ends up being 3x minus, I'm going to distribute the 10, so minus 10x plus 70. Now, minus signs can get very tricky. So anytime there's a minus, everything behind it needs to go in parentheses if there's more than one term. So I knew once I distributed this 10, I would have more than one term, so I'm going to put everything in parentheses so I remember that now I have to distribute this negative. This right here is where people lose points the most. So now I'm left with x squared times x plus 7 times 3x minus 10x minus 70. And again, remember you keep going until you cannot simplify further. So this is negative 7x minus 70. Okay, I look and I stop. I know negative 7 and negative 70 have a common factor of negative 7, which means we can factor out negative 7 from negative 7x minus 70. So I'm going to factor out that negative 7, put it in the front. And that's going to leave me with negative 7 divided by negative 7 is 1. 1 times x is x. Negative 70 divided by negative 7 is positive 10. And now all of my factors are in their simplest form, and I can stop factoring.